PLCs are designed to be programmed by a method that most plant engineers and maintenance personnel are extremely familiar with. This method is based on relay logic and is called ladder logic. Ladder logic differs from all other programming methods in that it's easily understood by those with little or no programming experience. It should also be noted that some PLCs might be programmed using Boolean algebra or mnemonic codes. This method is usually only used with very small PLCs and is rapidly being replaced by ladder logic. Throughout the PLCTrainer tutorial, simulations of actual PLC-operated programs will be shown. The simulator shown here will be used to display the operation of those programs and instruction sets. The simulator is easy to use and easy to understand. It consists of 4 important components. 1. The halt-run control. 2. The input activation panel. 3. The output indicator panel, not used in all cases. 4. The ladder logic program. The halt-run control will place the simulator in the run monitor mode, or place it in the halt mode. The run monitor mode will allow the ladder logic program to operate as it would on a real PLC. The halt mode will stop execution of the program. The input activation panel consists of a series of push buttons that will simulate the action of real-world input devices or field devices. This may include push buttons, limit switches, proximity sensors, photo sensors, and many more field devices. The output indicator panel will display indicator lights, which will indicate the actual operation of a real-world or field device, such as a motor starter or solenoid. In many instances, the output indicator panel will not be shown due to the need for additional screen space for displaying the program. The ladder logic program will be used to show the proper use of the instruction set being discussed. When the simulator is in the run monitor mode, the program will indicate the active or inactive status of each instruction. The simulator shown here will acquaint you with the operation and controls. Using your mouse, click on the arrow of the red halt-run control. You'll note that when you click, the simulator will change to the monitor mode. This is evident because the rails of the ladder logic program will turn green, indicating an active scan. Counter instructions are similar to timer instructions, except they are not dependent upon an internal clock. They receive their pulses from external sources. The counter will also require a preset value, PR, and an accumulated value, AC or ACC or ACCUM. When the PR value and the AC value are equal, the counter instruction is true. All programmable logic controllers operate their counter instructions on the transition from low to high, or the transition of the input from false to true. This is the case no matter whether the counter is incremental or decremental. Counter instructions are also retentive. That is, if the processor is placed in the halt mode, or if a power failure occurs, the counter will retain its accumulated value. Only the operation of the reset will cause the counter to reset. The counter shown here is similar to the format used by the Allen Bradley PLC-5. CTUs are capable of counting from minus 32,678 to 32,767. The counter instruction takes 3 words of memory. The first word stores the status bits of the counter. These are bits 11 through 15. The status bits are as follows. Count up enable bit, CU. This is bit 15 or bit CU. This bit is true when the counter rung is true. Bit 15 goes false when the counter rung goes false, or when the reset line goes true. The CU is used only with up counters. Count down enable bit, CD. Bit 14 or bit CD is true when the counter rung is true. Bit 15 goes false when the counter rung goes false, or when the reset line goes true. The CD is used only with down counters. Count up done bit, DN. The DN bit is bit 13. It is set true when the accumulated value and the preset value are equal. It will remain true as long as the accumulated value is equal to or greater than the preset value. Countdown done bit, DN. Bit 13 is also used here. The DN bit is true as long as the accumulated value is equal to or less than the preset value. The SCP, or Scale with Parameters instruction, is an output instruction that contains 6 parameters. These parameters may be integer, floating point, or immediate data values or constants. The SCP instruction is only available in SLC 5/03 processors and above, as well as Micrologic's 1200 and 1500 processors. All of the calculations needed for the SCL instructions are done by the processor when using the SCP instruction. The parameters needed by the SCP instruction are described below. Input, the value to be scaled. This may be a word address or an address of floating point data elements. Input min, the minimum value for the input, low end of range. This value can be a word address, a long double word address, an integer constant, floating point data element, or a floating point constant. Input max, the maximum value for the input, high end of range. This value can be a word address, a long double word address, an integer constant, floating point data element, or a floating point constant.